This lecture is a real romp through a lot of issues. The first one is I'm going to try to persuade you of how urgent the challenge is to achieve sustainability. It's really about the future of your lives. I'm going to talk a little bit about integrated whole systems. And I'm going to talk quite a bit about the environmental performance of public space, which I think is really underdeveloped. And then I'm going to try to persuade you with the assistance of neuroscience of how important these things can be in terms of creating a more meaningful place in the world. So, oh dear, the top erases the key point, which we are on a course for a 3 centigrade degree rise in the planetary average temperature, which will be a disaster for all of us if it happens. And the problem is really so ingrained in our culture and our economies. And the problem is more than just reducing carbon emissions to combat global warming. The problem is about the extractive, throughput, waste-producing, wealth-accumulating growth model of capitalism, which is leading, unfortunately, to the ecological collapse of all of the critical natural systems on which we depend, not the least of which is our food systems. Just look at some place like Pakistan. 1/3 of the country is still underwater, and it means that there are going to be 2 crops completely lost. So the solution is more than environmental design. It really has to do with transforming capitalism to a more ecological notion of economics. One where we try to get rid of waste, that consumption has to be balanced with how you can reuse the production of the system, or it can be absorbed naturally, and where the success is measured more on use value or quality of life and not on exchange value and the accumulation of wealth. So you as designers who are part of this amazing economic system, this is the larger context within which you're going to be, I think, trying to get to 0 carbon emissions. So one of the key concepts that I want to put out here, which has to do with the drawdown concept. Do all of you know what this is? Have you heard this before? This is Paul Hawken's group that has done this, where it's not just about reducing carbon emissions, it's about getting to the point where the Earth and its ecological systems can actually absorb the carbon we produce, where we can get to a point where our production in CO2 is less than our ability to absorb it in our forests, our oceans, our lands, and our agriculture. So this is the current situation where our sources of greenhouse gas emissions greatly exceed the ability of the planet in the sinks, which are the earth, forests, grazing lands, etc., and the ocean. So you can see right here, this is the gap in carbon emissions. So every year, we're putting this excess into the atmosphere. And we aren't even close to a drawdown situation, which is the diagram below, where your sources are less and you've built up the drawdown capacity here. So we actually reduce global warming. The trouble is, right now, this keeps happening year in and year out and is going up. And the consequences on extreme weather are going to be with us for 100 years. So we have to get to a model like this, where we have reduced all of these sources, improved the sinks, the ocean's capacity, forests, landscape, etc., and in the process, improve the quality of our society. And I think these can be done together. But this is the context within which we are designing our built environments. And if you just look at the US, another way to simplify this is if you look at buildings and transportation, they represent about 60% of the CO2 emissions, whereas industry and agriculture represent pretty much the rest. So there are three important ideas that I want to talk about, and I mentioned them at the beginning. One is to think of the buildings, your landscapes, transportation, energy, communication, water, waste, food, and the microclimate, all as one design problem. You're not just doing buildings, you're not just doing landscapes, or you're not designing transportation systems. These need to be thought of together. And if you do, there are all kinds of really interesting benefits across systems, a kind of synergy. The other thing is, as you'll see in a minute, the environmental performance of public space of cities, it's a huge amount of area, and it's underdeveloped in terms of its capacity to contribute to a more resilient and sustainable future. And it has the ability to make the public space way more meaningful. So why am I interested in environmental design at a community scale? Very simple, buildings are critical. I've worked on them for all my career in trying to make them better environmental performing buildings. And large utilities, they're critical, but they're too big and vulnerable. So you can do the whole systems integration best at a neighborhood scale, because you can work on the transportation, the energy, the water, the waste, the food. You can expand the role of the urban landscape or urban public space, and you can even do cogeneration and smart microgrids. And this has a huge impact on the ability for neighborhoods to be more resilient and smart. And in the process, you have to have social organizations that support these systems, which is really critical in terms of resiliency, because it's the social systems and connections that are important as the technology, and the impact on health and well-being is huge, including the aesthetic experience as part of the impact on health. So how did I, sorry, this is so sensitive. How did I come up with this idea of an eco-block? One is we did these projects in China where we were shown these amazing super blocks where you have these gated communities where you come through a gate, you go into these places. There are 5,000 to 10,000 units of housing. They were building these at a rapid rate. Actually, many of them are just empty now because it was a whole investment strategy. And in some ways, they're very interesting because they are a kind of gated community. And what is the Forbidden City? It's a gated community. What is a Huton? It's a gated community. So there's a kind of acceptance of the idea that you want to belong to a place that is yours and private and gated, but the impact on the city is huge. This is what they look like. 10,000 units of housing on a city block, which is approximately a quarter of a mile square. So we asked the question, could we design something different than a super block, which required a huge amount of energy, produced incredible dependence on the car, got rid of walking and biking, and depended on being able to dispose of a huge amount of waste. So we got some money to look at this. We did a project first, which showed that these neighborhoods really did have a huge potential for being resource self-sufficient. And we designed a neighborhood in, remember the sketch that I showed you before with all those tall buildings, those blocks? We took 3/4 of it and made it into streets, small walk-up blocks with towers in a park along the edge. We provided a public transit system that was walkable from the neighborhood. And then this was the key diagram. First of all, you take the buildings and you make them incredibly energy efficient. And you'll see how in a minute, you know, really good envelopes, good windows, low air infiltration, good daylighting, etc. And then you have lowered the demand on energy to be able to be provided by wind and solar on the buildings. But what was a critical discovery was we could use the food waste, the sludge from settling tanks, and the green waste from the gardens, and move them to an anaerobic digester to make biogas that could create electricity. So we were filling the gap with waste. And in the meantime, we could take the effluent from the septic, treat it in living machines, and then put it back for the gardens or toilets, or you could even do some advanced ultraviolet disinfection and have it for drinking water. This was this is 2005 when we discovered that you could do this. And we were really excited about it. So you can see really good building design, natural ventilation, passive solar, daylighting, really good envelopes, efficient lighting, efficient appliances, shading the public space, changing the paving, etc. And then providing the energy source from these 3 sources: solar, wind, and biogas. I'm hoping the next one shows this. Yes. No silver bullet. You have to do all these things. But the key thing is if you do what could be described as conservation and efficiency, you can reduce the load 60%. And now with some of the passive house standards, you can actually reduce it way more than that, which means the photovoltaics, the wind, and the gas has a much simpler job and can be much more manageable in size. When we did these initially, we only had the digester doing a little bit, but it can do actually a lot more, as we learned. The digester technology is really advanced. It's a 2-phase thing, so it's much more efficient. So you get a lot of good methane, you get water, and you get fertilizer out of the process. It's incredible. Here's the diagram: primary treatment, liquids and solids. And you can see on the bottom, you get hydrogen, methane, and compost. So in effect, what you're doing is you're taking the energy out of what traditionally would be compost. You can also run it through a living machine where you cycle it through an aerobic and an anaerobic set of tanks. So the water goes in here, sits for a while, it's eaten up by some bacteria, then it goes into a place that's dry, it's eaten up by other bacteria, and you cycle it, you collect the water, you can measure the quality and use it for the right use. It looks like a garden. This is the lobby of the, the energy building in San Francisco. This is Esalen. This is in Las Vegas. This is in Vermont. You know, when it freezes, you have to put it in a greenhouse. We did a whole bunch of projects trying to show this. This was going to be a project down on the peninsula for a piece of land that was going to be a whole research center and hotel and housing. We used all of our knowledge from passive solar, daylighting, wind and energy conservation, and did these little step downs to show how laboratories, low-rise housing on podiums, high-rise housing, and even large laboratories could be zero carbon. We couldn't get anything built. We tried to build the project in China. It's a long story. The Chinese are very risk adverse.
2 weeks ahead on Calcom.
But it was also
like right now.
a lot of, unfortunately, corruption at the associate mayor level. Hearing some talking. Is that me? Okay. So when you're an academic and your big idea is not able to get built, what do? You go on sabbatical, you go to all the early versions of this, and then you write a book about it. I'm going to go through these pretty quickly because you can look them up. It was really fun to do this. I went to about a dozen to 15 different neighborhoods and then chose 4 because they really represented what I thought were the best examples of how you could do integrated whole systems thinking. You know, it was fairly descriptive at first and analytical, and then I tried to draw lessons learned. And I looked at the development process, transportation, the urban form, the green space, energy, water waste, the social agenda, and resilience. There are 4 projects, 2 in Sweden. 1 is in Malmo. This is Malmo here, Boa 1 right on the coast. And this is Hammarby in Stockholm. This is Stockholm, this is Hammarby. And then 2 in Germany. 1 is Vauban and Freiburg, and the other one is Kreuzberg, which is right outside of Hanover. Why won't it go? Oh, okay. We could go through this a lot if you're interested in the urban design. All of the projects really use a perimeter block concept, but each one is slightly different. Boa 1 has this amazing view to the Öresund, and then it has these blocks with really wonderfully rich, almost medieval-like internal things. Hammarby has these perimeter blocks that open up for views. Kreuzberg has these perimeter blocks that get smaller and smaller in scale all the way to the landscape. And Freiburg produces these blocks with fingers that allow you to look into the blocks, which are really interesting. Transportation is perfect. It's so, the standard in Europe, you know, you only have to walk 300 meters to get a stop. It's sheltered. The headways are, you have to wait, you know, 8 minutes at most. It's really connected to where you want to go. You have a wonderful pedestrian environment to get there, great streets, dedicated bikeways, limited parking, and of course it's subsidized, so it's very affordable. We should have free public transportation in this country. The planning was really interesting. Boa 1 was supposed to be a housing expo. It was a housing expo, but designed by a single master planner. Hammarby was designed by the planning department in Stockholm. Kreuzberg was a competition for the plan. And then Vauban was really interesting because it was done by a series of local Baugruppen, which are cooperatives that bought the land and did the design work actually hired the builders. They were their own contractors, and it performed amazingly. We could go through all the blocks. They're really interesting. What I loved about this project is it's basically all low-rise, high density with one tower. And so you get the advantages of both. High density from the tower, but there's only one, so it doesn't block all the views. And these places, you're hardly aware of the tower. This is this is Kronsberg, where you can see it had parks at each end and schools around them. So it had a south and a north end, wonderful blocks. This is Hammarby with these units that had views of the wonderful bay here. These are the finger blocks where the commercial is at the end of these buildings. So you do have a commercial street, but it looks into the courtyards. And then you have one of the highest performing little neighborhoods off the street. It's right here because it's photovoltaics, passive solar, really good insulation. It gives back energy to the city. The most important thing that I learned from all of this, which is actually why I wrote the second book, is about the public space. This urbanism is very different than a lot of cities. The green space that's integrated into the higher density is what stands out. They treat the water, they create incredible parks, and suddenly the environment now is performing in a way that in most cities, this stuff is just put underground and gotten rid of. So the big takeaway was a different notion of how we make urban public space. So after that, when I came back, I said, well, why don't we try to do this right in our backyard in Oakland? You know that most cities in this country were built before the Second World War in close-in neighborhoods like this. We got a lot of funding, a lot of help. 40% of the housing stock in California, believe it or not, is not in the suburbs. It's in these close-in neighborhoods. And if we're going to get to carbon neutral, we have to find a way to retrofit these. So the challenge was, could we do this? Could we make these neighborhoods more zero carbon? Could we actually help the microclimate given the heat waves? Could they get to zero carbon? Could we charge EVs? Can this be rapidly deployed? And can they be funded by the savings in utility bills? So this was the idea: make a community solar on the roofs where you collect it with a DC system. You can store it, all DC. You can come back and do street lighting and charge cars. You go to one inverter. That inverter then can take the energy back to the houses or to the grid. Pretty simple idea as a microgrid. You can also do a lot with the water. It's crazy in California that actually capturing rainwater makes sense for 2 months and actually using it. But you could also take water out of the sewer, mine the sewer. The biggest water resource in California is wastewater. It's completely dumped, and it is a huge volume. Why should we be throwing away and using drinking water for the purposes that we currently do it at and then throw it away? So we looked at the idea of taking water out of the sewer, treating it to remake the microclimate. In other words, changing the tree cover. And where is this important? The Central Valley, Southern California, where we are talking about a disaster in terms of the urban heat island effect and problems in urban neighborhoods. This is what it looks like. It's now about to start construction. It has been a nightmare to try to get this done. And the biggest problem has been the utility, who's fought us every step of the way. We actually think if we can prove to them that this is a good idea, they might actually adopt it and stop being people who are so opposed to this. I won't go through all of these things, but it really does have a huge number of benefits. We're doing this from the savings of the utility bills. We're converting to a completely renewable energy source. We're charging PVs, and actually the money saved in running PVs, EV electric vehicles from PVs, is part of the economics. You can do about 40% of the vehicle miles traveled. Critical is shifting from gas to all electric so that you're not polluting the houses. But again, going back to what I said, in the very beginning, it's all about the improvement to the public space that I got a glimpse of when I went to these wonderful sites in Europe. So I tried to characterize what the public space of cities do. And I worked on this and did it afterwards, and look at all of the functions. It tempers the microclimate. It improves the air quality. It absorbs CO2. It treats the stormwater. It can treat wastewater. It can grow food. It creates habitat. It actually can be space for generating energy, but it can also create the fuel for energy. And then if you look at the last ones, it is a tremendous opportunity to create a beautiful place and to involve the full sensory engagement of the city. And that has a huge impact on your health and well-being. The final three, recreation, community, and transport, and primarily transport, although we do have wonderful parks for social interaction and recreation space. But that's what public space has been primarily thought of. The first 10 functions are underdeveloped. What I love about this is the UN has recognized this and said public space is critical to achieve their sustainability goals. It has to do with health and well-being, equality, work, climate, and environmental performance. So what about the public space of cities? Represents anywhere from 35 to 75% of the public space. And if you know, most streets, it's mainly streets, but some parks, and they're treated pretty generically. And let's look at how we've looked at public space. So there's a very formal compositional tradition that the public space of city is a spatial formal exercise. So you're really interested in the sequences, the type of spaces, and you can see an older tradition where buildings make space, and you can see some of the more contemporary modern traditions where buildings are objects in space. But it's really a spatial game. Then you have a very alternate approach, which is to worry about the social performance first. This is Jan Gale, where you're interested in what functions you're trying to support, and you provide the facilities that enhance that and enable it and afford it, and then the architecture frames it. There's been a whole tradition over the last 20 years, 25 years of livable streets, which is to transform our streets from just being primarily car-oriented to being a multimodal place for pedestrians, bikes, public transportation, as well as the car. And it's a very rich tradition, but is only modestly being applied in the United States. And then there's, of course, this vision of what public space does. It basically gets rid of everything. Underground, it hides everything. Here's the old throughput system. Get it away as fast as you can and dump it in the sewer and get rid of it. And here's this newer tradition where we use it for multi-functions. So remember all these functions? So why is the environmental performance of public space so important? Because given global warming and the urban heat island effect, if we don't do anything, many of our cities will be uninhabitable for large portions of the year because of overheating. And in many cases, it's the only place that many publics exist. So this is really a vital social problem. I won't go into the urban heat island effect, but most of you understand what happens. Cities reflect all the sunlight. They are absorbed in the materials of the city and re-radiated at night, so it never cools down. Buildings dump all of their excess heat from air conditioning into the city, and cars and vehicles dump their heat into the city. So there is a huge heat buildup in the city where they can be as much as 14 to 16 degrees hotter than the outlying countryside. So, you know, I'm a passive solar pioneer. I really believe in the building envelope as an environmental filter where you try to get the good stuff in and keep the bad stuff out. The problem now is you don't want to dump the bad stuff into public space. So the design of building envelopes now is much more of a two-way challenge. You want to provide comfort on the inside of the building, but you also want to pay attention to the comfort in the public space. And it really means re-examining every single surface of the city. The walls, the floors, the sidewalks, the roofs, the gardens. It really is the place where this operates. That's why when I was in studios today with Benjamin and other faculty, I find this section one of the most loaded and interesting ways to understand how buildings can be more responsible to the public space of cities. So one of the things we did is look at all the surfaces, look at urban floors, look at all the functions that clean stormwater, retains stormwater, charges groundwater, tempers climate, absorbs carbon, improves air quality, creates habitat, blah, 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 okay? What a benefit. And it has all these dollar improvements. Saves costs on water, energy, carbon costs. It's good in terms of health, community value, and it enhances the senses. Look at these floors. Amazing. Evaporative cooling, improves comfort, tempers the microclimate. Look at the walls. You can put a new screen up, make a new urban space in front of it, create a shaded area behind it. You can shade facades. You can actually make whole buildings out of green in the city. All the same eco-functions and co-benefits. Just some more examples. I love this one because it's a very lightweight steel structure, but the living plants are the one that turn it into a building. But you could not have this be an object. All of this stuff could be put around the city to make entirely new green rooms. What about canopies? They're spectacular. Trees are amazing. They're probably the best investment that cities can make, even though you have to maintain them. The traffic engineers don't like them. They are incredible in terms of the qualities that they add to urban neighborhoods. Oops, wrong way. You don't have to just do trees. You can do all sorts of fabrics and canopies, and you can make them dynamic. You pull them shut during the day, you open them at night for the night sky cooling, and they make wonderful spaces. You can see just some examples. You can also change the section dramatically. as you can see here, for this Masdar, and this is also the Sony Center in Berlin, here on the right, lower right. Sorry. The canopies can generate energy, make a huge difference. They provide shade, but they also provide energy. They can be of all sorts of materials. They can even be green. Oops, I'm going the wrong way. And you can also go be on top of them. You can have a parasol and be underneath it. You can paint the ceiling, the roofs white to reflect the solar energy. This is on top of the Oslo Opera House, a wonderful place. And you can do all sorts of other things, grow food, have gardens. You can even make whole new neighborhoods with bridges between, the roofs. You can also use the parks. They can be sewage treatment plants. These are two parks in China, in Tianjin, that are actually treating all the stormwater, all the wastewater of these housing in the distance. So again, the urban section, absolutely critical. And I just put this up here to review the point that the floor is a whole design opportunity. The walls are not just for the building, they can belong to the city. The canopies, the same thing, and same with the roofs. They're a huge undeveloped opportunity, even though. So in appreciating this, I really realized that one of the problems with sustainable public space is that the aesthetic and sensorial have not been part of the discussion or really the design challenge. And yet, at the same time, neuroscience has been reminding us how important embodiment theory and the senses are in terms of constructing meaning in our lives. So I really wanted to go back and look at the environmental performance of public space to see if some of these insights from neuroscience really were operative, and if we could remind the urban design fields of how important that was. So here's some of the insights. First of all, the desire for meaning is not just an elitist urge. It is as primal and as fundamental in almost every culture in the world. In some cases, it's practically on the level of food, because people, in many cases, they have very little in their lives, but if there is a meaningful place that they can exist in the public world, it's as important as it can get. It gives them meaning and hope. The other key thing is mirror neurons. And this is an incredible thing that was discovered by being able to do, brain scans and brain imagery. So when we see a cup, it's not just visual. It activates all of these neurons in our motor and premotor cortical areas. And it activates them as if we actually picked up the cup, held it, drank from it, felt its warmth, smelled the coffee. So the perception is much more dynamic and sensorial, and also almost precognitive. The other thing that neuroscience has shown us is that meaning is embodied in the functioning brain, so that when we see objects, we understand them not just for what they're being used for right now, but what we remember them to be used for, what we could imagine them to be used for in the future, so that the neuroscience is showing us that our perception and environmental cognition is very, very deeply embedded in our experience of the world and that sensory experience of the world. So it's not just an abstract concept or disembodied, it's rather It involves all of these neural simulations of sensory and motor and affective processes. So just look at some examples. According to neuroscience, we experience through our mirror neurons the battle with this snake. We dance the dance. We feel the weight of Magritte's boulder. We understand Matta Clark's slice and slump of these two parts of the house. It completely engages us, and we also appreciate the process. It's not just that we see the cut and empathize with the slumping. We try, somebody had to cut that. So we understand the process. Same with this wonderful painting here, where you can imagine the extent to which paint was applied and then scraped across to get this blurry image, which is almost like what you might see in a puddle on a sidewalk. It's an extraordinary recognition that our appreciation of something is not just what it looks like, but we understand the process by which it's made. Oops, I keep going the wrong way. Also, we have two kinds of attention. Everybody's talked about the two hemispheres, but I find it really interesting that the neurosciences said our first impressions are from one part of the brain, and then we go back and try to understand if it really meant something to us, how and why it meant something. So it's the narrow focus of the left side, which helps us understand why we really were attracted to something which we didn't fully understand in the right side. So it gives us two ways to be in the world. And apparently this was critical to our evolution and survival. Also, in the process of living our lives, we build up these image schemata, and they're embodied form. So we understand from the time we're little, where we climb in and out of boxes, what it means for containment. We know what verticality is because we struggle to stand up, and we can jump. If you've seen kids just jump, 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 it's a completely embodied knowledge of the world. The same with balance, the same with forces, and the same with motion. And what I find so interesting is that helps us to understand some of the form concepts that we've been taught about in architecture. And these are some of the classic moves where you take a point and you slide it and it makes a line. Oops. You take the line and you slide it and it makes a plane. You take the plane and it slide it and it makes a volume. And all of a sudden you can have volumes that are operated on by subtraction. There it is. Or addition. Little saddlebags on the side of Charles Moore's condominium. And then we can appreciate the diagrammatic formation of things. These are some of Eisenman's diagrams where he starts with a simple transformation and then elaborates it. But this is an even simpler one. The idea that you draw people up from a walkway into the public space that folds back on itself, that creates the platform on which the galleries exist. We empathize. This is a haptic, gestural move that neuroscience says we understand in a profound way. So we said, let's go take a look at some public spaces and see if we can see these insights from neuroscience as being more operative than we realized. So I bet a lot of you have been to Paley Park in New York. It's this amazing little vest pocket park. So first of all, it reduces the temperature in New York City in the summertime by 10 to 12 degrees. This is measured. And look at what it does. It does much more than a technical solution. We simulate the gestural ideas of first a forecourt. You can see the gesture here, and then the enclosure of the room behind. It's made up of wonderful walls. We can occupy it in multiple different ways. It affords many ways of being in the space. It has incredible environmental performance, shade, evaporative cooling, evaporative transpiration from the trees and the ivy on the walls, huge sensory engagement, the sound of the wall, the touch of the materials, the feel on the skin, the dappled light. So this is a pretty profound space, and yet it's kind of everyday, but it has snuck into our imaginations and stayed there for these deep reasons. So we have this visceral knowing of this place that's extraordinary. So that's New York. This is Venice. This is Scarpa's little courtyard off the side of the Biennale galleries. I don't know if any of you have been there, but it is the most soothing and restoring sensory experience I've ever had, because you've been in these galleries, you've seen all of this art, you know, your brain is saturated, and you walk through a door and suddenly there's the sky, green enclosure, and shade. And then there are a whole bunch of other things. There's sound, smell, light. It's amazing. So it's a hugely powerful place. It does have this little shading device that has round cutouts. So it's in contrast to the very rigid room that you go into. You can see, and they're cut out in the corners, so it kind of semi-expands the space. It's a really brilliant place. Scarpa was really good. Here's one of the wonderful things. When you go in there, it is really cool. You can find shady places to sit. You can find all sorts of different ways to occupy the place. But they're fountains. And you see this little water fountain here? This is a copper lily. It's like a lily here. The water hits this and makes music. And what happens is the ringlets, where are they, around this get reflected on the soffit of the shading device. So you have a visual echo of the sound of the lily and, you know, the smell of this water. So suddenly this is a place of amazing sensory delight. So one of the things we did for the book is we said, well, let's take some pretty iconic places and let's really try to blow some people's mind and redesign them. So you all know where this is in Barcelona? This is the Plaza Real. It's a Renaissance square that was put into medieval fabric, and you come off of the Ramblas here and you come into this courtyard. It is unlivable until 11 or 12 o'clock at night because it's so hot. And it's going to be even worse given the heating issues with global warming. And the reason is because it's not shaded enough on the floor, so it absorbs heat, and all the facades are masonry, and they get heated up by the sun. So even at 9 o'clock, it's still almost 100 degrees in this space. So we said, well, what could you do? Suppose you shaded all the facades with an energy generating canopy and you had green fins that kept the low sun from hitting the facades. And let's say you put the fruit orchard in one end, which was there originally, and you put canopies on the south end. Here they are. So you're doing this. And you do it in such a way so that it fits in with the architecture. It was just to show that we may have to remake spaces like this in the future. And furthermore, this would be an amazing place because the way you irrigate the orchard is it's a flood irrigation. So when you go there at night, the stars come down from the sky and are in the floor. It's a really, if you've ever been in an irrigated orchard at night, it's one of the most poetic places you could be. So it's trying to bring back, rather than just a few palm trees and a medieval sculpture in the middle. So that was just to try to suggest that we could be a little, we could, suggest some real changes. So then we also said, let's go to Harlem. Harlem, a disinvested neighborhood. It has practically no tree cover. Let's take the streets that are, symmetrical. Let's put all the parking on one side. Let's get 3 rows of trees down the middle and increase the shading by 80%, change the temperature, and you can see the kind of activity that you have. You're absorbing the water in these parking spaces here, and you've completely transformed this place. And then you take the avenues with practically no trees on them, and you do a canopy that is closed during the day and open at night, so you get the night sky. And you turn, 50 blocks of Harlem into an oasis. Just another. You could also take the cross streets that are really wide in New York. There are 5 of them, or 6 of them. You could make a hanging garden that's an energy generator, and it's an 18 megawatt power plant. So you could run all of the street lights in Lower Manhattan from this thing. And you could make a hanging garden and completely transform the experience from going from one river to the other. It's just to show that some of these sustainability ideas can be more than just a technical solution. So that's what we tried to do in this book. I urge you to get it. It's really fun. You'll see 8 case studies. The key thing about this is an invitation for all of the architects and landscape architects and city planners to go back to public spaces that are part of their visual imagination and try to understand what has made them that way, to expand the number of examples so that when you go to design the public space of cities, you take these into account, because this is what's going to make our cities livable. So thank you.